Okay, let's look at 2012, step 1, question 5, another calculus question, which is quite nice. So show that from 0 to a quarter pi, sine 2x ln cos x dx is equal to a quarter ln to minus 1. Okay, so what sort of integration technique can we use here? Well, if we observe that sine 2x is 2 sine cos, then you would, you see an obvious substitution, right? Just go u equals to cosine, basically. If you go u equals to cosine, then it solves the problem really, right? Because the sine dx, I could get rid of it, right? Because I know du equals to minus sine x dx, right? So the sine dx becomes minus du, which is nice, right? So this integral sort of becomes, or the limits you could do yourself. This becomes what? 2 times u ln u du, okay? Or well, maybe there's a minus in front, whatever, okay? And how do we do that? By parts, right? By parts. Okay, so this is easy enough to evaluate, right? Just by parts. So that sort of equals to, something like, well, choose this one to differentiate, right? This one to differentiate, and this one to integrate, right? This one to integrate. So it will become, okay, some constant, which I don't know what that is. I have half u squared because I integrated a u, ln u, minus the integral of what is that? Well, ln u differentiated to 1 over u, yeah? And then I have my half u squared as well. Du. Something like that, okay? Well, with some constant adjusting, which you could do, right? Trivial. Okay, and you'll get the result there. If you put your limits properly, then you'll be fine. And that, the next part, now cosine 2x this time, interesting. Ln cos x dx equals to an eighth pi minus ln 4 minus 2. Okay, this one is not as nice, right? Because this one, I can't make the substitution and eliminate the sign, right? I can't make such a substitution, which is slightly trickier. Okay, but being inspired by the first part, you sort of know that some by parts thing is going on, right? So you probably want to do by parts, right? So what can we do? Well, let's do this by parts, and you'll see this is actually manageable. So do by parts on this. Then what do I have? So I want to integrate the first thing, okay? Integrate the first thing. Differentiate the ln. Okay, so whenever you do by parts, whenever you see ln, basically you always differentiate ln. Yeah. So let me integrate this. So this becomes a half sine 2x times ln cos x minus the integral of, now differentiate properly, so 1 over cos x, but by the chain rule I need to multiply that by minus sine x. And what does cos 2x integrate to? Well, that becomes a half sine 2x, right? dx, like that, okay? So this thing is quite nice actually, if you have a look at it. So, okay, whatever the first bit is, minus, what is this? Well, the minus goes in front, right? So I have, what is this? So sine 2x is 2 sine cos, by the way. So the 2 cancels out with the 2 here. Cosine cancels out with the cosine. Then what do I have? Sine squared dx. And this one is a classic integral, right? Pull out the double angle formula for cosine, then you're done. Okay, and put in the limits properly, then you'll be fine. Okay, standard A-level calculus there. Okay, the most juicy part is the last part, right? So hence, evaluate this thing. So now, there are actually a couple of hints in this expression, right? First thing is, what is going on here? Why are the limits changed? Right? Now, but the thing is, the interval, the range of the limits is sort of the same, right? Because it's still a quarter pi apart. That should sort of give you a hint of what the substitution might be, right? And now, look at the second bit. I have cos x plus sine x. Now this, you ask me, how on earth does that resemble that? The cos x, right? Now what if I did something like this? So let's say I put something like this in there. Let's go something like, okay, consider cosine x cosine pi over 4 plus sine x sine pi over 4. Now this could be contracted to cosine of x minus pi over 4. Now then this is exactly that, right? You just make a substitution, right, of x minus pi over 4. And you know that cosine pi over 4 is equivalent to sine pi over 4, so you could factorize that. So essentially, I'm just adding a constant in front of this bracket, which you could get rid of later. Okay, so all these are giving you hints as to what the substitution ought to be, right? Okay, so let's use the limits way, right? Because the limits sort of is more obvious, right? So let's make substitution. U equals to what? So I want the limits to become 0 and a quarter pi. So maybe x minus a quarter pi is sensible. Yeah, just to adjust the limits. Okay, so what does this integral become? This integral becomes I equals, it's always a good habit to write I equals, yeah? The integral equals, from 0 to a quarter pi as I planned it, cosine of what? 2x minus pi over 2 now, 2u, sorry. No, 2u plus, okay, I'm being really dumb, 2u plus pi over 2, yeah? Now, what are the other ones? The next one is plus sine of 2u plus pi over 2, and then what's the ln bit? Now I bracket this, ln cosine u plus quarter pi plus, what is it, sine, I can't write properly, whatever, sine u plus quarter pi. Yeah, all good? Okay, so now I have to think about, okay, what is cos of 2u plus pi over 2? What do you think that is? Or if you really don't know what that is, okay, if you really don't know what that is, you can expand the thing, right? You can always play safe and go cos A cos B minus sine A sine B. That's absolutely fine, right? So this one is just minus sine 2u, yeah. And if you again play safe, let's go sine A cos B plus cos A sine B. So this one is what? Cos of 2u. Okay, how about the stuff behind? So the thing after the ln seems really annoying, right? Seems like there are lots of terms in there, but actually not, right? Think about this. U plus a quarter pi. So this is cos A cos B minus sine A sine B, i.e. Root 2 over 2, which is the cos quarter pi bit, cos u, minus root 2 over 2 sine u. Okay, and same here. The remaining bit is plus root 2 over 2 sine u plus root 2 over 2 cos u. And the beautiful thing is, that cancels. Hello, that cancels, right? And okay, I sort of moved it for some reason, but then you close the bracket, and you obviously have to close the integral as well. And then what happens? Okay, observe. What's this? Look, what can you do with the logs? Let me write this in a nicer way, putting the positive thing in front. Well, what can you do with the logs? This is what? ln root over plus ln cos u. Right? Okay. Now break the bracket here. Separates it, right? Then what's the first part? The first part is cos 2u minus sine 2u and what? Multiply that by ln root 2 over 2. That's just a constant, right? No one cares. And you know how to do this. This is just linear trigonometric functions, right? I'm not sure why the 2u is up there. Yeah? Okay, plus what? What is the second bit? That's just what? Okay, let me call this P. Let me call this P. Let me call this Q. Okay, then what is this? This is just Q minus P, isn't it? Right, look at it. The first bit is cosine 2u times ln cos u. That was my Q. What was my P? It was sine 2u times ln cos u, as above. Right? So here, you could evaluate this yourself, right? And you know the result for Q and P. Then you're done. Right? So it's quite a lovely question, right? So it's quite hard to spot the substitution, I suppose. Yeah. So I've given you some advice on how to spot a substitution. The limits is the main thing, and also spotting the connection between ln and the ln cos plus sign there. Yeah. And a classic technique is to chuck in the 45 degrees. Yeah, because sine and cosine are equivalent for 45 degrees. That's a classic technique. All right, cool. Quite a good question.